Stop the transcription. All right, I think we should be good. Thank you for reminding me. All right, so just a recap, a quick recap. Dispersion measures how spread out your data is. Okay, so if I just do the histograms again, a rough sketch. Clear this. Okay, dispersion tells you how spread out your data is. So this curve, which is quite narrow, versus the curve below it, which is spread out. This distribution is more dispersed. Okay, and we're going to talk about ways to measure that dispersion. All right, and that's what we're going to do today. So first, we're going to do it for ungrouped data, and then we're going to do it for group data. All right, so let's look at ungrouped data as an example, and that's the data you have in the top there for credit card spending. All right, so we've got credit card spending. We have 1, 2, 3, 4, 5, 6, 7, 8 data points. In other words, we have the spending of 8 people, all right? And we track their credit card spending for the month. Now, one of the first measures of dispersion is called range, all right? Range is very easy to calculate. Range just means how basically the maximum value minus the minimum value. What is the width or the span of the data, right? So range is very easy to calculate. It's just the maximum. Now I've ordered the data for you. Okay, so I put the minimum on the left and the highest one on the right, 5,400. So your range is the highest, which is 5,400, minus the lowest amount, which is 3,200. Okay, and that will give you the range. If you subtract that, I think you should get about 2,200. Right, it's very easy to calculate. Okay, so let's go on to the more tricky measures of dispersion. Right, and we can use our calculator to get them. One of the measures of dispersion is the standard deviation, which is denoted as S. Now the formula for S isn't given, but the formula for S squared is given, right? And if I've got the formula on the right here. This is given to you. You don't need to memorize it. Okay, you just need to know how to use it. So the formula is sum x squared minus n x bar all squared divided by n minus 1. Now we're going to calculate this S squared, which is known as the variance, in two ways. We're going to do the long method and we're going to do the short method. You need to know both, because if the mark scheme is, say, 3 marks or more, right? So if it's 3 marks or more, do the long method. If it's less than 3 marks, use the short method. So let's do the long method first. To do this, we need our calculator. All right. The first thing I want you to do is get your calculator out. We're going to store this data. Now I showed you how to capture this data in last week's session. All right. So what you need to do is on your calculator, okay, you're going to press the mode button and you're going to choose the stat option. So mode, then you're going to choose the stat option. Okay. Once you select that, then you would choose the option that says 1 minus bar. Choose this option, 1 minus bar. All right, and everyone's calculator should have this X and a frequency column. Now I showed you how to set this up last week so that your calculator always has the frequency column, right? I can go over that a bit later, but I'm hoping everyone watched last week's session before they're watching this one. So I'm going to check the chat if everyone's okay. Any questions? Nothing. All right. So what I want you to do now is I want you to capture this data, okay? On your calculator, in the X values, you're going to capture all of this data. Okay, so the first value we capture is 3,200, and it equals to. Then you would capture 3,750, and it equals to. So I want you to capture all of this until you get to 5,400, right? I'll give you a second to get there. Don't worry about the frequency column. It gets automatically populated as one. So we just ignore the frequency. When it's ungrouped data like we're doing now, you can ignore the frequency column. All right. Capture that now. I'll give you a minute. And then we're gonna use the calculator to get our variance. If someone can just give me a heads up that they finished captured, so that you have an idea where you are, I'd really appreciate that. So in the chat, just say done, so I know you've captured the data. Thank you. I appreciate that. Thank you so much. All right. So everyone's got the data captured. Okay. Now remember, we're going to do the long method first. All right. The long method means you have to show the values for each term in that equation. Okay. So we're going to get all the values for the terms in the equation. So the first term we got in that equation is this thing here, sum x squared. Now we need to get the sum x squared value. So we're going to use our calculator to do that. All you need to do is to get this value. Okay, you're going to press shift, then you're going to press the button 1 because it has stat above it. And you press the button 1. All right. And if you do that, you'll see on the options number, my calculator is 3, is you're looking for sum. You're looking for the option sum. Okay. When you select the sum, you will see this symbol here. You will see the symbol here. And you will select that one and press equals to. And when you do that, you'll get a value of about 161,000. I'll write out a number here. You will get a value of 161,682,500. That's what you would get. It's going to go to the chat. Okay, so far, I think everyone's okay. All right, so we got our sum x squared. The next term we want to get in the equation is your n. Okay, you want n. Now n is the exact same way as we did above. So we're going to do shift. Okay, then you're going to select 1, the number 1, and then you're going to choose the option bar variable because n is a variable, it's not a sum. Okay, so you're going to choose the option variable, and you'll see n there. Select n and you press equals to, and you should get a value of 8. Okay, so now your calculator is doing all the work for you. It's finding the values for the equation. Okay, so your n should be. All right, so we've got our n. Now, the next thing is the x bar all squared. Now, your calculator will give you x bar, but it won't square it for you. You'll have to do it. So I'll show you how to do this in one step. We're going to find the x bar and we're going to square it. Okay, so you go to your calculator, you press shift just like before. Okay, you're getting pretty, I know it's becoming monotonous, but you will eventually this not even give it a second thought. It'll be so second nature to you to figure this out. So shift 1, okay, and you'll choose bar. You're looking for a variable, and you look for x bar. Okay, then you select x bar. All right. Once you get x bar, now remember we want x bar squared raised to the power 2. So when you do that, okay, after you select it and you set equals to, right, you just press the button after this and it'll squeeze this button here. You'll see on your calculator you're looking for an x squared button. If you press this and press equals to, it'll automatically square the x bar squared. All right. Or if you want, you can just leave x bar and then square it later. It's up to you. So basically what you're doing is you're doing this. You're taking x bar, which is 44443.75, and you're raising it to the power 2. Okay, that's what you're doing. Okay, I'll just check the chat now if anyone has any. But okay, I think everyone's no questions, but please let me know if there are. All right. the value you get for this, I won't write it here, okay? So it's quite a big number, but I'm going to show you the final result of how we get the S squared. Okay, so we got everything we need to put into this equation, right? So like I said, in the long method, you just need to show the examiner that you know how to find the values in the equation. So if I'm just going to replace everything in the equation with the values itself. I'm going to put all these values in. So you got your S squared equals your 161,682,500 minus your N, which is 8. Okay, gonna let me make some space here. Okay, 8 into your X bar, and your X bar is this here, all squared, which is 444,3.75 all squared divided by N minus 1, which is 8 minus 1. And if you work that out and you put into your calculator, you will get a value of 529,000. I'll write the number out to you. 599,598.21. That's your S squared. So that's your variance. Okay, that's your variance. 598.21. If you want the standard deviation, that is your S. S is your standard deviation. Now, S is simply just taking the square root of S squared, taking the square root of S squared. All right. So if you wanted it, all you need to do is you find the square root button, and the square root button looks like this. Let me erase this and show you on the left. Okay, there's a square root button on your calculator that looks like this. It's that, and it's got a block inside here that's shaded in white. That's your square root. So for instance, if you wanted the square root of 4, right, you would press that button, right, and you'll see a bracket pop up. You'll see this, you'll see a bracket, and you just type 4, and then you close your bracket, right, and you press equals to, and you get 2. But instead of 4, we are going to put this number in. All right. If you do that, you'll find your S value is 727.73. So just to give you an idea, the mark scheme for something like this, just to get your S using the long method, is about 5 marks. All right, so you do need to know how to do all these steps. It is a lot of steps as I've shown you, but you need to be comfortable using your calculator to find the values for the equation and then putting the values into the equation to get your S. Right, and remember, this formula only gives you S squared. You still need to take the square root of it in the end to get S. Let me just check if there's any questions before I move on. All good? Please do let me know if you have any questions. I don't mind going back. All right, I think everyone's good. All right. Okay, so that's how you get your standard deviation. All right. Another thing you can get asked is for your coefficient of variation. Okay. Now you may ask, what is the coefficient of variation? You don't need to memorize the formula. I'll give it to you now. Find it out. Okay, the coefficient of variation is this formula here. It's CV equals S over X bar as a percentage. 0%. All right. Now, you already worked out your S. We did our X bar earlier. Okay, X bar we worked out. It is, tell you now, it is 4443.75. So if you want this, all we need to do is just substitute your S and your X bar in it. And if there's your S, there's your X bar. So you're taking this number here and you're dividing it by this number and you express it as a percent. And if you do that, you'll get 16.38%. So this is something else you can get asked, and you just need to know how to do it. Okay, so when they ask for coefficient of variation, you're looking for CV. That's the abbreviation. CV is coefficient of variation. Okay, before I move on, are there any questions? No? All good? Okay. Go back to the board. All right. The next thing you can get asked is for percentiles. All right. Now, let me explain what percentiles are. Okay, before we start doing the calculation. Get this board. Okay, intuitively, you may have heard of it. So when people ask, when you wrote a test, right, in the class, sometimes you feel, I don't want to be in the bottom 25% of the class, right, or in the bottom 10% of the class. Intuitively, you kind of understand what you're trying to say, right? If you had to rank the class, and if you had to look at the lowest 10%, so if you had 100 students, right, if you had 100 students, 10% of them would be 10 students. And you would feel, I don't want to be amongst those 10 students that got the lowest marks. What you're actually saying is, I don't want to be amongst the 10th percentile. That's what you're saying. There's also the other end of the spectrum. There's the top 10% of the class. So if you had 100 people, then the top 10 people that got the highest marks, if you had to rank them in order, and you take those highest 10 people, then you're amongst the top 10%. But that is the 90th percentile. Why is it the 90th percentile? Whenever we talk about percentile, we talk about that being the maximum. So for instance, here's 90%. So everyone, this is so if you had 100 students, here's the 90th student. Everyone below this sits below this student's mark. Everyone here, this is the top 10 students. That's the top 10% of the students. You'd generally, if you wrote a class test or something, this is where you'd want to ideally try and sit, right? If you're a high achiever and that's what you're trying to be. So when we say the top 10%, we're saying the 90th percentile, because everyone that got below what the 90th person got, if you had to rank them in order. So that's what percentiles are, right? There's special percentiles that we give a special name to. When it's the 25th percentile, or 25%, in other words, a quarter, the 25th percentile is the first quartile. It's the same thing as the first quartile. In other words, the first quarter. All right. The other special percentile is the 75th percentile, which is known as the third quartile, because 3 quarters. So the 75th percentile is the same thing as the third quartile. They just get a special name, but all they are is percentiles. Okay, does that make sense before I move on? Let's check the chat. I'm hoping everyone's following and everything makes sense. But please, if anything's not clear, please do let me know. Thanks, JD. I really appreciate it. All right, let's go back. All right. Now let's try and work these out. Okay. So we understand intuitively what they mean. Let's work them out. Okay. For this first example, let's look at the first quartile. In other words, the 21st percentile is the same thing. Right. So the first thing you have to do is make sure your data is ordered. Okay. So we've done that already. Okay. That's the first, that's the second, third, fourth, fifth. And we put them in ascending order. You have to do this in order to find your percentiles. All right. Now, if we want the first quartile, and we denote the first quartile as Q1. Okay, so Q1 is your first quartile. So what we're saying is, we want to know at what spending, credit card spending, does 25% of the people lie below? And we need to find that. So the first thing you have to do is find the position of your first quartile. So you find the position. All right. Now to find the position, you need to use this formula here. It's n plus 1 all over 4. That's for the first quartile. Or you could remember it like this. It's the same thing as saying 0.25 or 25%, 0.25 times n plus 1. Right, that's to find the position. This is the same thing, right, as dividing by 4, 25%. Your n is how many data points you have, and we have 8 data points. That's what your n is. So we substitute n into that, and then you do that, you'll get 0.25 times 9, which is 2.25. Okay, so that's just the position. Okay, just remember that we haven't found the first quartile yet. That's just the position. This is just the position. And what do we do with this position? What the position tells you is where that person lies. Okay, these are your positions. These are your positions. All right. Now this is 2.25. If we had, hypothetically, let's say we got a number of 2. Instead of 2.25, we got the number 2. Then that's very easy to work out. All that means is that it's the second person. It would be this person here. If it was a perfect 2, but we didn't get a perfect 2. What we got is 2.25. So there's a decimal involved. And that means we have to be a bit more exact. So we're saying, yes, it is the second person, but that 0.25, that's 0.25, means it's not exactly the second person. It's somewhere in between the second and third person. It's somewhere in between. And we need to work out what that in-between value is. And how you do that is, first, you take the number in front of the decimal, 2. So we know it's the second person. So it's the second person, right? So the second value, what is the second value? It's this here. The number that corresponds to the second position, which is 3750. So 3750, that's the second number, plus, and this is where this decimal is going to come in now. The decimal is saying it's somewhere in between the second and third. And how much in between do we need to go? Well, that's what the decimal is. The decimal is 0.25. And we're saying it's 0.25 of this distance, 0.25 between these two numbers. And how do we get the distance between these two numbers? Well, you just subtract them. Subtract the highest one from the lowest one. So it's the 4,200 minus 3750. And if you do this whole working, you'll get a value of 3885. That's the first quartile. That's your final answer for the first quartile. I'm just going to pause there and check if there are any questions. Oh, good. Okay. So remember, once you get the position, if you get a perfect whole number, then it's very easy. If it was a 2, you just take the second number. If it was a 3, you take the third number. All right. What corresponds to position number 3? It's as easy as that. But when you get a decimal, it adds a bit of complexity to it. And this is how you use that decimal. Okay. This is how the decimal comes into place. You will take the second number, which is in front of that decimal. What number corresponds to the second position? Well, it's this number here, 3750. So that's how we got this number here. Then we add a difference using the decimal. That's plus 0.25. This is where the decimal comes in. This decimal is here. And we take the difference between the third and the second number. Please. Does that make sense? Anyone want me to repeat that before I move on? Everyone clear on this? Maybe I'll do the third quartile, and maybe that'll consolidate in. Here, I'll do the third quartile as well, and make sure everyone's following. Okay, so that's the first quartile. All right, now we're going to work on the third quartile, which is Q3. So our steps are to find the position. In the position, we use the formula. You can use this formula here, 3 into n plus 1. That means you must work out what's in the brackets first, and then multiply by 3, and you divide it by 4. Or you could do it this way, 0.75, because third quarter is 75%. 0.75, the same thing, into n plus 1. Right? Either way, we'll give you the same thing. Our n is 8. So if you work this out, you will get 0.75 times 9, 6.75. Now that's just the position. 0.75. So this is just the position. Now, if we had just got a number of 6, the job would have been very easy. You just take this number here that corresponds to the 6th position. If we had got a 6, but we didn't. We got a decimal as well, and that means we have to use this decimal. So what we do is we take the number in front of the decimal. That's position 6. So the 6th position. What number corresponds to that? It's this number here, 4,800. Okay, plus now this is where this decimal comes in. So 0.75 times, okay, we're on the 6th and 7th now. So you look at the difference between the 6th and the 7th. So it's just 5,200 minus 4,800. If you work this out, you get a value of 520. Does that make sense, everyone? Are you following? All good? I'm just gonna make an assumption. Okay, all right. Okay, cool. Thanks for the feedback. Again, now how do we interpret this? Okay, so it's one thing working it out, it's another thing interpreting it. Okay, so we did all the hard work, we've got the value, and I'll show you how to interpret it now, right? We found our third quartile. Yeah, we'll write the values here. 5.20. Okay, we work this out, and it is 5.20. And the question is, how do we interpret this? Right, now remember, what are we talking about here in terms of our data? We're talking about credit card spending. If this is the third quartile, that means 75% is what we are actually looking at. So we're at the 75% mark. That's the third quartile. So what we're saying is, third quartile is the amount of credit card spending where 75% of the sample spends below. So that means 75% of these people, 75% of, we can say, these clients spend less than 5.20. That's how you interpret it. Okay, does that make sense? When you're interpreting an answer, don't just say the third quartile is 5.20. You need to interpret it like how I've shown you here. So it's very important that you understand what these values mean. Okay, so I'm just going to check the chat. No questions. All right. Now, so far, I've done the first quartile and I've done the third quartile. Now, let's do it for an odd percentile. So not the special ones where it's 25% or 75%. Let's say 70%. Okay. So you asked to work at the 70th percentile. Okay. So we follow the same steps as before. Okay. We find the position. Now, instead of writing Q, I'm just going to write P. It's just notation, right? It doesn't make a difference. I'm just writing it different because, say, it's the percentile. All right. First, you're going to find the position. And the formula to find the position is, remember, it's a 70th percentile. So that means 70th percent, which is 0.7. 0.7 times n plus 1. So n is 8. So we work that out. Okay. And we get a value of 6.3. That's just our position. So we're not done yet. We only found the position. All right. Now, we didn't get a perfect number 6. Neither did we get 7. We got a decimal. Okay. So we follow the same steps as before. We take the number in front of the decimal, which is 6. So it's a 6 number. 6 number, which is, it's still 4,800. Plus, this is where the decimal comes in, the 0.3. Times the difference between these two numbers, the 6 and the 7. So it's the 5,200 minus 4,800. If you work that out, you get a value of 4920. And then we must interpret this, right? So we interpret it by saying, remember, we worked at the 70th percentile. So we think 70% of the sample spend less than 4920 rands. Okay, that's how you would interpret it. So you'd say 70%. You could say of clients or the sample, of the sample, spend under 4920 rands. Always interpret it in terms of the problem. We're talking about credit card spending, so you interpret it in terms of credit card spending. All good? Everyone okay? I'm going to assume that's a yes. All right. Okay, so pretty much covered ungrouped data. And now I'm going to cover group data. The principle is the same. What you're trying to work out is the same. It's just that the data is presented to us in a different way. All right, so I'm just going to maybe just close this and reopen it so I can get a clean board. Actually, you know what? Let me just erase everything. And I'll put some group data in this whiteboard. Okay, so let's say we got some group data. Here, I'll copy this first. All right, so what we have is the same data we had as last week. We had grocery spending, right? And we use this for central measures. So typically in your exam, you would be given these two columns, right? You wouldn't be given the third column, but I'll show you how to work that out. And we've done that last week. So what you're told here is grocery spending amounts, and we're given the bins. So in other words, people who spend between 0 and 400 Rand in the first row, there's nobody that spends that amount. That's why the frequency is 0. But for people that spend between 400 and 800 Rand, well, we have 7 people that spend that amount, okay, etc., going all the way down. In total, we have 30 people. How did we figure out 30? Well, if you add up the frequency, you'll get the total number of people. This 30 is what your N is. Okay, that's what your N represents, the total frequency. N is 30. All right. Now your midpoint is what you'd have to check, you'd have to determine on your side. But it's very easy. All you're trying to do is you're getting the midpoint of each bin. So if you look at the first bin, it goes from 0 to 400. The midpoint is just adding the upper limit, 400, plus the lower limit. We divide that by 2, and we get 200. And that's how you get this 200 here. You do that for every row going down. Okay? That's how you get the midpoints. Right? And your midpoints are your X values. It's very important you know that, because in your calculator, it'll ask you to give it the X values. And you need to know that that's the midpoints. All right, so what we're going to do is we're going to store this data on our calculator now. Right now, we've already stored some data in our calculator, but if you press mode again, all right, it'll erase that data. So that's what we're going to do. We're going to press mode, and you're going to choose the stat option. Mode, then you will choose the stat option. Okay, and then you'll choose the same option, 1 minus bar after that. Okay, and then everyone should see something like this on the calculator, X, the frequency. Now we're going to use the frequency column. Okay, you're going to use the frequency column because you're going to store these values here under frequency. So you're going to start from 0, 7, 14, etc., all the way to 1. 1 is the last number. Okay, and then your X are these values here, 200, or 600, all the way to the last number, which is 2,200. So could you just do that for me? And someone just indicate in the chat when you're done. All right. So you'll need to store these numbers, because I'm going to show you how to work out the values using your calculator. I'll come back to this. I was going to check the chat. Any questions? Yeah, come back. Very good. That was fast. Okay. Can someone else just tell me that they're done? Nikachi, I think you're working very fast. So I'm just going to make sure someone else also managed to do it. But very good. Hey. Can I go to the chat again one more time? Okay, we're all good. I assume everyone's good. I'm going to move on. Okay, you got your calculator. You stored it. All right. Now, we're going to work out the variance S squared. Again, just like what we did for group data. But sorry, just like what we did for ungrouped data, but we're now going to do for groups. There's two methods. It's the long method and the short method. All right. Let me do the short method, because we did the long method before. And the short method is actually something I just need to show you. If you see the marks is just 2. If the mark is, say the question says, what is the standard deviation? Let me just say this. Question says, what is standard deviation? And the question is only 2 marks. You only see 2 marks for it. In that case, when it is, you're going to use the short method, okay? Because the marks are under 3. And I'll show you how to do that. So for the standard deviation, the symbol for that is S. You must know this. You need to know what the symbols mean. So they're asking you to work with S. To get S, it's very simple in your calculator. All you're going to do is you're going to press Shift. Then you're going to press 1. Then you're going to select the option bar, variables. And in there, you would see something like this. An S with a subscript like this. Okay, that's the same thing as this. They are the same thing. So you'll select that and then press equals to. Can you write down what number you get in the chat? I just want to make sure everyone's following here. Write down the value you get for S in the chat. Come on, people, you're going to have to do some of the work here. Make sure that you're following. Excellent. That's it. That's the short method. The answer is 416. So that's the shortcut. Okay, so everyone make sure you understand how to do that. Okay, that's the easy way to get the standard deviation. Okay, all right. Now, that's the shortcut. The long method, okay, just gonna make sure you understand how to do it in the long way. I won't do the whole thing, but I'll give you an overview of the steps needed to get it, because we did it for ungrouped data, so the principle is the same. Okay, you've got your... Okay. For the long method, you have to use this formula here. I'm gonna shade it in green to draw your attention to that. Okay, you'll see there's a bit of a similarity between these two equations. They're both S squared, but the difference is now we're using the one with F in it. Why? Because F is frequency, and for group data, you get frequency, so you have to use that. Okay, the formula there is S squared equals sum Fx squared minus nx bar all squared over n minus 1. So it's very similar to the one we did before, except now there's an F there. Okay, there's an F there, that's the difference. But the good thing about that, about your calculator, is that your calculator already takes that into account. So if you want this value here in your equation, if you want this value, you need to get this symbol in your calculator, because it's the same thing to group data. This and this is the same thing for group data. So in your calculator, if you can get this, and I showed you how to do this earlier, then you've essentially found this here, this what I've encircled. It's the same thing. So how you would do that, if you don't remember, I'll just give you a recap. I'll change the color here. Okay, you will press Shift. Okay, 1. And then remember, we are looking at sums. That's what the symbol is, the sum. Okay, these are sums. So you will look at the option that says sum. Then you will see this here. Okay, select that and write the number down that you get when you do that. Write it out in the chat. I want to make sure that you're following how to do this. What do you get for this value? It's a long number. What, 40,000 something? Can you just write down what you see? Yeah, very good. That's right. Okay, everyone should get this, but if you don't, you can let me know, and I can talk you through it. So you get 40,000. Okay, 880, I think. So you get. I'm using commas to just kind of separate the thousands. Yeah, that's what you should get. So now you know how to find all the other values. I showed you how to do it earlier. How to get n, how to get the n, the x bar. You can square it, and the n is the same the denominator. Only difference is this, and you know how to do it now. You found it. It's this value here. Right, and you substitute everything into the formula. You'll get s squared, and that's your variance. And then finally, if you want s, you just take the square root of whatever you find here. So you would say s equals the square root of whatever you get for this entire thing here. That's the long method. So if you see the question is asking for 3 marks or more, do the long method, okay, for the standard deviation. Okay, I hope that's clear. Okay, any questions? Let me just check the chat. What he said. All right, let's get this out. All right. Okay, now we're going to do percentiles and quartiles for group data. It's a bit different because we have to use a formula for this. Okay, now I'll talk you through this formula. But if you understood how to do the median last week, it is pretty much the same thing. All right, it just has a bit of different notation, but that's not a big thing. All right, if you followed how to to do the median last week, then to do these percentiles and quartiles is pretty much the same thing. Let's do the first quartile. For the first quartile, we're going to use this formula here. All right. You don't need to memorize it. You just need to know how to use it. So it's, I'll write it out again a bit bigger. So it's Q1 equals OQ1 plus C into N over 4 minus F of less than all over FQ1. That's the formula. The trick is to just figure out how to get the values for the terms in this equation. So just like we did last week for the median, the first thing you need to know is where would the median be positioned? Okay, and it's the same thing for the first quartile. Remember, we have 30 people here, 30 shoppers. So if we were talking about the first quartile, we would be talking about a quarter of them, all right? So in other words, we're saying 0.25, first quartile, 25%. You can either say N over 4, or you can say 0.25 times N. It's the same thing. Now you'll notice there's a bit of a difference to how we did it a minute ago for ungrouped data. Before, we did it this way. We did N plus 1 over 4. But here, there's no plus 1. Now, I may disagree with this a bit, but this is how the course works, okay? I do think it should be consistent for grouped and ungrouped. But I didn't make the rules, everyone, so sorry. The formula is N instead of N plus 1 for grouped. So remember this, okay? You have to apply a slightly different formula for grouped and ungrouped. Okay, so just remember this. For Q1, for ungrouped, it's N plus 1 over 4. This is for ungrouped. For grouped, it's N over 4. There's no plus 1. Just remember that. Okay, it will make a slight difference. So make sure you remember that. There's no plus 1 when it's grouped. That's why there's no plus 1 here. Right. Now our N is 30, right? That's how many shoppers there are. So you just substitute 30 for the N. And if you work that out, you'll get now 7.5. Gonna clear this. 7.5. Let me check the chat if there's any questions. All right. Okay. Now, for group data, we can't really work with the 0.5. Right? Why? Because we don't know the exact values. Remember, we know there's 7 shoppers that spend between 400 and 800, but we don't know the exact amounts. So what we can do is we have to round this. We'll always round it up. Okay, so we'll always make it the higher number. We'll make it 8. Okay, we round it up. So even if it's 7.3, okay, even though it's less than 0.5, round it up. Okay, remember that. Okay, we round up always. Okay, so let me erase that. Okay, so remember, what we did so far is we just worked out the position. So it's the 8th person. Now, just like we did for the median last week, right? We looked for where the middle person would be. So if the middle person would be the 15th person. Because we've got 30 people, so we try and figure out where would the 15th person be. But now we're not looking for the 15th person. We're looking for the 8th person, 8th position. So the 8th person will definitely not be here in the first row because there's nobody there. Okay. He won't be in the second one because going from here to here, there's only 7 people in total. So you can't have the 8th person there. But when you get to the third bin, you have 21 people because 0 plus 7 plus 14 is 21. So that Q1 has to be in this interval. It's very important you know how to find that interval. So the Q1 or the first quartile person is positioned in this interval. Right? Does that make sense before I move on? It's very important you identify how to determine that interval. It's exactly the same like how we did it for the median last week. Okay. If you're not sure, just drop me a message and I'll happily go back. right? Okay, so we know that bin is where the first quartile person lies. And so every single term in this equation that you see here comes from that or is determined by that interval. So your OQ1, okay, this OQ1, rewrite it. This OQ1, yeah, that's the lower limit of that interval. And if we're talking about this interval here, the lower limit is 800. Your C is the class width, and that is how wide the class width is, and that's 400. Okay, because you can see it goes from 800 to 1200. So if you subtract the upper limit, 1200 minus the lower limit of 800, you'll get the class width of 400. N over 4, we've worked that out already. Okay, that was about 7.5, I think. N over 4, all you do is substitute N here, which is 30. Right, that's your N. Now this F of less than, very similar to how we did it last week. What we're saying is, it's the cumulative frequency, so you add up the frequency for the intervals below it. So we're saying add up these two frequencies. So the frequencies below that interval. So 0 plus 7. And that will give you 7. And then the last value is the value in the denominator, FQ1. That is simply the frequency of that interval. That is 14. So you substitute all these values into this equation, and you'll get a final value of, I'll tell you now, 814.29. For your final answer, let me write it in the side here. After you substitute, 814.29. That's your first quartile. Does that make sense? Everyone following? Any questions on that? Oh, good. Okay. All right. So now you know to work the quartiles. The last thing I will do now, right? I will slightly over time, but it shouldn't take too long, is to do it for any percentile. Okay. So you could be asked to work out the 80th percentile. So let me show you how to do that. Okay, this is the last one, then we're done for tonight. Okay. Say the question asks you to work at the 80th percentile. I'll write like, this is the 80th percentile. And you got to figure this out. Okay. What you do is, sometimes you will be given this formula here, but even if you don't, it's still pretty easy to work it out. And I'll show you how to do that. All right. Before, remember, we worked out the first quartile, we use this formula here. Or we use this Q1, okay, equals OQ1 plus C into N over 4 minus this F of less than all of FQ1. All right, you can actually just change this formula for any percentile, okay? This Q1 only, remember, it means the first quartile. So what we need to do is work out where this 80th percentile would be, the 80th person. And then we use that same formula as before, 0.8 times N. And now N is 30. So if you work that out, 0.8 times 30, okay, we get 24. So we get a perfect whole number. So there's no rounding needed. So what we're saying is, where is the 24th person? All right, so then what we do is we start going down the frequency column to see where that person would lie. Okay, so the first frequency is 0, so he definitely can't be there. The next frequency is 7, can't be there because we're still under 24. Right? When we get to the third interval, we're on 21 people because 0 plus 7 plus 14 is 21, so it's still not there. It has to be the next one. Okay, because when you get to here, there's 26 people. So this is where your 80th person would be, the 24th person would be here. In other words, your P80 interval is this one. Okay, it's this interval here. So I'm going to mark it in red so we can not lose track of that. Second. Okay, we're on this interval here. This is where your 80th percentile person would be. Okay, it's the 1,200 to the 1,600 interval. All right. So now all the values that we need to work this person out comes from this interval. Now we don't need to use the same notation for the Q1. We're going to change the formula for the 80th person. So we don't need to say Q1. Okay, we're going to change that. This is the 80th person, right? So we can call it whatever we want. You can put an OAT subscript if you want. You can put AT here. Now this will change because this is n over 4. This is your first quartile. We're not talking about n over 4. We're talking about 0.8 times n. We're talking about this, the 80th percentile. So 0.8 times n. That's it. And that's our formula. So the same principle applies. Okay, this is the lower limit of that interval, which is 1,200. Okay, so this is 1,200. Okay, the C is your class width that doesn't change. Your class width for every row is the same thing. So your C is still 400. Okay, C is 400. All right, the 0.8n, we worked this out already. It's 24. So that's 24. This f of less than. It's the same principle. We're on this interval now, okay, where the red mark is. So that's the cumulative frequency before that. So everything before that are these three. So it's 0 plus 7 plus 14, which is 21. Okay, you add up the frequencies for every interval before that. So 0 plus 7 plus 14 is 21. And this F80 is just the frequency of that interval that we're referring to. And that's 5. So you substitute all these values into the formula and you'll get a value. Okay, your P80 is 1,440. That's your final answer. So basically, 80% of the sample spends less than 1,440 rand on groceries. That's how you would interpret it. All right, does that make sense, everyone? Everyone good? That's what I want to cover this evening. Are there any questions? All right. Well, I hope this was helpful. And I hope the assignment's going okay. And you're enjoying this course. If there's any questions, yeah, feel free to just drop me an email. I have been getting some really good questions and corrections as well. I'm very appreciative of that, and it's good to see students are working through the content. All right, we'll chat soon, and yeah, have a good evening, everyone.